All right, friends and neighbors, welcome back to part 2 of our QoS build. And so just a quick recap, let's go through it. Right, we are talking about quality of service. And so we are taking a layer 2 cost value and mapping it to a layer 3 DSCP value. So our layer 2 cost values are actually found in the 802.1q header. They're out front here. They're the class of service bits. We also set these on the ports in the switch. And then we're going to map these to layer 3. And so here's our DSCP values. We know now that those used to be IP type of service bits that nobody uses anymore. And so they're actually the first 6 bits of this 8-bit field. And so there's some funkiness that goes on when you're trying to understand the values that are here. Now the values that we use are maps the values that we use are described in a map that we select. You can use a lot of different maps. The one we're using is the cost to DSCP value. This is a common map to use. And so a layer 2 cost value gets mapped to a layer 3 DSCP, and you can see that right here. And we did the conversion in the previous video, so we found out that a cost value of 7 gets mapped to 56, and we figured out how that actually works. So it's the 6 bits in the DSCP field. Okay, so that's where we are. We are going to set up the phones in this particular half of the video, this particular part, and then we'll do our class map and policy map and service policy, right? We're going to label, or we're going to identify the label that we want to use, that we're going to provide the treatment for those labels, and then apply it to an interface. All right, there we go. Let's go back over to Packet Tracer. So here is our Packet Tracer build. Remember that we've got serial interfaces installed in our routers. Now the reason that I put this in here is so that we could, I was hoping to simulate a low bandwidth connection. And we could drive this down if we have time. Maybe we'll fool around with the clock rates. And we'll see how that goes. And then we'll try to protect it with QoS. But right now we're just going to get it all set up, and I'll show you how to do it. All right, so we've already set up our VLANs. Let's do a little recap. So we'll do a show VLAN here. So we already have our VLANs. Remember that we have our static routing. What we haven't done is our telephony, and we haven't done our phones, and we haven't done the quality of service configuration. All right, so let's do the phones first. And you'll notice that these links are down, and that's because the phones are not actually up and running. Now, one of the things when you're setting up an extension, right, a lot of times these are VoIP phones, but they used to be called Ethernet phones because the phone number is based on the MAC address, not the IP address. And so it would be really handy if in here somewhere we could find the MAC address. Thank you. Thank you. But we don't actually see that. And so what we're going to do is we're going to pull it from the source address table. It's a nice little trick, but as the warning message keeps telling me, I got to turn the thing on. So I'm going to take my little power here, and I'm going to say, let's turn this phone on. And now I'm looking at port 1, and so I'm going to take this address, and we'll do the telephony configuration, and then we'll do the same thing with the other phone here. And you can actually look at the GUI and see that, the phone is actually starting to configure, and this is actually interactive, right? You can take the phone off hook when you get it all provisioned and everything. So now, how am I going to learn the MAC address of this phone? Well, if I do a show MAC address table, MAC address table, I can see that port 1 this is the one for the phone. Now we'll do this too, just so we can generate. I'm going to generate some traffic here. We'll ping. Oh, look at that. There we go. So the trace works now. And now if I look at the MAC address table, I can see that we got different VLANs, and then on port 3 I have this MAC address. And what I'm waiting for is this port to come up so that my phone can appear in my MAC address table. And so we're waiting. Oh, you know what I could do? Let's do this too. Config T Let's go to int. Hey, let's use the range command just for fun. Interface range 0/1 to 2, and we'll say spanning tree port fast, so we don't have to wait. There we go. All right. And we'll do our show MAC address table again. Let's do. Come on, darling. You can do it. Maybe what we'll do is we'll reconnect. There we go. All right, all right, fine. It wants to play hard to get. It's all right. It's all right. We get more than one way to skin a cat here. So if I do a show IP DHCP binding, now sometimes the phones just take a little bit, and we have no IP. It's not even trying. Oh, let's see. No, I did the trunks. Let's see. What are you trying to do, Mr. Phone? All right. I'm gonna remove power. And we're gonna power it back up again. And all that we're trying to get is it to reveal its MAC address and also test our DHCP server, right? We're giving IP addresses out from the router. And in a DHCP configuration, if you don't have an interface live on that particular network, then you're not giving out IP addresses for that network either. And so what's our GUI say now? All right, so what I missed here was that it's going, there we go. I missed the first message. But hopefully this is generating traffic. Hey, look at that, port 1. Okay, good. So I want this MAC address, so I'm going to copy this. Copy that MAC address. Let's go up to our router now. And now it's time to work on the telephony stuff. So we're going to say config T, and I'm going to say telephony service. And let's do max ePhones. A very common value here is 10. Oops, max ePhones. Hello. All right, let's do IP source then. We'll start there. Now this will be the IP address of the router. Now we also want to do the port here. Now the port for SCCP is 2000. There we go. And are you going to let me do max ePhones now? Oh, I forgot the dash. Max ePhones 10. Max. I did it again. See, max dial numbers. We'll have those match, and that's pretty much what we need to do. Now we'll also do the create CNF files when we get those done. Now it's packet tracer, so it actually works a little bit faster in many cases than a real life build. But there we go. And we're going to do ePhone 3. Now, so if you just, this is going to drop us to a new prompt. So we're going to do ePhone numbers here, and you see the limit because we're at Call Manager Express here. We're going to do ePhone 3. Now there's two parts to an ePhone configuration. We want the ePhone itself, and then we want the phone number. So what do we need here? Well, we need the MAC address that we just copied. So ePhone 1 is going to have a MAC address, and we'll paste this in here now. There we go. And let's do the button command. 1 will be 3, so that'll be on the phone. Yeah, we got to do the dial number first. Sorry. So let's do ePhone. Now the other commands here are the dial number, and that'll be for the corresponding phone. Thank you. And we need a phone number. Now on the other side here, all of these phones begin with 475 and then ... There we go. Oops. So over here we'll just do 476. Pretty common example that I use. So on the router then, right? What are my options here? I need a phone number. Hey, look at that. So this is how we tie the MAC address with the phone number. So the number here will be 476, and we'll make it with the ePhone then. We'll say 0003, like that. Okay. So just we'll take a look at the config all the way down here. Right, so we've got our ePhone dial number and our ePhone itself. Now let's go back in and do that button command. That provides something for the interface. So we're going to do ePhone 3. Now the button is the actual button on the phone, and then what number you want to tie that button to. So like that. Okay, good. I like that. Let's do the same thing with our other phone here. And we'll power it off again. Let's see, or we'll power it on. Now that everything's up and running here, we'll power up. Notice that the spanning tree port fast, the ports, they should, spanning tree port fast not going. Oh well, the phone has an internal switch in it too. Whoops. Now we want port 2 this time. There you are. And we'll copy that one. Alright, so Packet Tracer is sort of ignoring my spanning tree port fast commands. So we'll exit this, and I will say ePhone 4 MAC address. Paste that one. There we go. And we'll do ePhone. Whoops. This will be dial number 4. And we will say number 476-0004, and we'll go back over to our ePhone, and we'll say button 14, like that. Alright. Now, why my switch ports are being a little bit persnickety here. We have spanning tree port fast going. Alright, fellas. And while we're waiting, let's take a look at our show IP DHCP bindings. Nobody yet. Alright. That's alright. We'll wait. We'll wait. Now let me show you when it actually is working. What you can do with the phones, the nice thing is that you can actually say, so I'm going to call from one to another here, and we'll provide some more labels here. This is actually phone number 475001. This is 475002. Let's change our labels here on these to what did we do here? ePhone 3. This is ePhone 4. And so when I want to dial, you can see that the phone, or I don't know, maybe that's really small. Can we zoom in? Zoom in? Whoa. Still really small. Alright, I'm not going to worry about it then on the topology. Alright, but the phone number right here is 475-0001. And so if I wanted to dial 475-002, I would just like that, and I would pick up the phone, and it's dialing. And then I go over here to this phone, and I say, pick up the phone. So there we go. And if I was running the simulation, I would see that the SCCP stuff is going to the call server. But eventually we'll drop into RTP. There we go. There's our RTP stream. There we go. So the call is working. We'll go back to real time so I don't fill up the buffer. And we'll hang up the phone. There we go. All right, call ended. Why you two are giving me such a pain here, giving me such a hassle. There we go. I don't know. But in the meantime, what I'll also do, we'll start the configuration on the phones, and we will say, let's go to, we'll do 01 first. And what I'm going to do is, well, globally, what we do is we say MLS QoS. So we're going to enable QoS. And what we can also do is, maybe I'll show this to you. In Packet Tracer, it's not letting me configure the map that I want to use. But if I do a show int f0/1 switchboard, actually maybe a show QoS for f0/1. Oh, for heaven's sakes. There we go. We can see that I'm using a DSCP mutation map. So it is mapping cost to DSCP automatically. And so let's go into the interface and we'll just say MLS QoS. Now if we take a look at the options that are available here, I'm going to set a cost value. And this will be my layer 2. This will be what appears in the 802.1q frame. And then what I'm going to say is MLS QoS trust costs, because that tells it that it's okay to map this to layer 3. And if we say the same thing on, port 2, now 7 is the highest, right? It's just easy to see because an E appears. But normally voice would be, say, 5 and 3 for signaling and for transport. Let's see, what was I looking for? There we go. And maybe I'll do, we'll set a different value on port 3. We'll say port 3, maybe we'll set a, we'll just do it as a 1. There we go. Okay. Well, if we run our simulation here, and what I'm going to do, what I'm interested in is what's heading up this trunk. And we'll see if the values are changing. So this is all on the other side. Maybe what I'll do is we'll just we'll ping our default gateway. There we go. So we're going to let this go. There it goes. And then now we want the one that's going up the trunk. All right. So if we look at this value right here, we know that the VLAN is 44. So if we do 2 times 16 to the first, which is 32, and then we add 14 to it, we get 44. Sorry, what did that? So we take 2 times 16 to the first, we get 32. And then C is what? C is, let's see, A is 10, 11, 12. So we add 32 and 12, we get 44. Now 2 is that value in the first hexadecimal value. So it's the first 3 bits, and so that value is a 2. But remember how the bits are actually set. It's actually a hexadecimal character based on 4 bits. The cost value is 3. So it's actually in that first 4 bits, it's 0010. That's why this appears as a 2. And the same thing occurs right here. So clearly we've got our mapping working on our trunk line. Okay, let's see. Where were we? The buffer was filling up. I did some changes under preferences. You can do that. I'll just quickly, let's see, miscellaneous buffer filtered events only. That appears to have cleared up a lot of it. Okay, so here's where we are, right? We've got our routers set up and we did all of our static routing. And I did a little work on dial peer on this side. We'll do that here in a second. But if we remember, right, we've got all of our routes. And what that allows us to do is ping from one side to the other. Now the reason I touch back on this is because we're about to set up call routing. And call routing, so we'll wait for the ARPs to go here. There we go. So we have to do default routing so that, or not default routing, we have to do static routing so that we can tell the routers how to get to various network destinations. And whether we're doing dynamic routing or default routing or static routing, doesn't really matter. The point is that we are telling the routers how to get to different destinations. Well, as we can see here, this phone is 476. Hopefully y'all can see that okay. If we zoom in, is that a little bit better? Maybe. 476-0003. And over here, we've got 475. So if I come over here, we'll go ahead and do that. If I try to dial this, if I say 476-0003, right? It's an unknown number because the call server has no idea how to get there, or at least the receiving call server can't figure out how to get over there. So I set up a dial peer on this side, but it needs to be two ways. So here's what we have to do. We have to tell both call servers how to route to those telephone destinations. Remember that a telephone number, we all know the area code, but the second set of three numbers, that's the office code, and then the last set of four numbers is the station code. So let's do this. Get out of here. All right, so config T. So now what we're going to do is tell our router on the right how to get to those phone numbers over there. And so we're going to do a dial peer. And this is, you can just sort of follow the prompts here, but we have a number of dial peers that we could set up. So this is going to be a voice dial peer, and we're not going to have very many of them. So we've got some keywords that it wants us to use. So this is our VoIP. Okay, so this is our first dial peer. And what are we after? Well, we have to do two things. We have to tell the call server about the dial pattern that we're going to use, and then we have to tell it, because we're doing voice over IP, the IP address of the receiving server, or at least a router that can get us there. Now we only have two routers. It's pretty straightforward. But if we take a look at our options here, the destination pattern, okay, that's pretty straightforward. We want to be able to get to 475. But 475 anything, so dots are our sort of wildcards here. And then the session target, so who are we going to send this to? Well, this will be an IPv4 target, and we'll try the other end of the link, which is 10.0.0.1, because that's attached to that same router. Okay, now I did the same thing over here. And we'll take a look at our dial patterns. There we go. So on this side, we've got a target that's the other side of that link, but we have a different destination pattern. Okay. Well, let's try our phone number again. And fingers crossed. Again, 0003. Hey, we're ringing now. So now if I come over here, and we pick up. All right, so we now have a phone call going between the two sides. All right, well, what does all that mean? So again, we did routing statements to tell us how to get to IP network destinations. And now we've done telephone routing to tell us how to get to different dial patterns. When you're setting up a SIP trunk, or when we do those later, we'll realize that we're essentially talking about the same thing, right? We are going to set up SIP patterns or dial patterns that get us to a set of extensions that are owned by another SIP server, and that is enacting what we call the SIP trapezoid. All right. Now I can tell already we're going to be a little long on this video, but the whole point of this video was to build this topology, get ourselves a little bit of practice, but also to do the policies. So let's review that for a sec. So we've done lots so far, but here's the QoS stuff. The first thing we're going to do is create some class maps. That is to say, we're going to decide what we're going to match, and then we're going to do some treatment for those policies, and then we're going to apply that to a particular interface and a direction. Now on the switch, we have some quality of service stuff to do. Remember that we're talking about port-based security or port-based quality of service. So that's why these are on a particular port. And remember that we're using this particular cost to DSCP QoS map. Whew, that's a mouthful. All right, so let's go back over to our switch and make sure we got everything set up right. And I'll worry about 2 ports at this point. So we're going to go to int f0/1, and I'm going to say, oh, let's actually do switch as a whole, MLS QoS, and then we'll go to int f0/1, and we're going to say MLS QoS cost level, and we'll make that 7 just so we can see it. And then we're going to say, because we want to map it to layer 3, we're going to say MLS QoS trust cost. So that is to say, whatever cost value you get, push it on up to layer 3. And then we'll go to int f0/3, and we're going to say MLS, that'll just be a 1, and we'll do that. Okay. Now if we watch the traffic here, and hopefully we don't overflow our buffer again. And I'll just sort of keep this going. We'll run our simulation first, I suppose. And what we want to see, and I think we saw this before, but we'll just verify. Right? We're going to advance here, and we got some SCPs. Oh, did I add? Let's go ahead and add ICMP. There we go. Well, we can grab the router as long as we grab the right side. But so let's do this. There we go. All right, so we got our VLAN, and we can see that we're doing some marking here. But importantly, it's moved up to layer 3. All right, so that looks pretty good. Now, let's go back to real time. And on our router, what we're now going to do is we're going to define our policy. So we're going to say class map, and I'll use the words from the slide, right? We just need a word here. And so what we're going to say is, we'll say that this is gold. Okay? Now what do we want to do? Well, we're going to match a DSCP value. Remember, these are policies on a router, so the router is going to pay attention to what's in the IP packet. So let's say that we want to match, well, what do we want to match in our gold class? What we're going to match here is the actual DSCP value. And so if we take a look at these, they got a whole bunch of them. But what we're after is the one that we just set, which is right here. So we're going to say CS7. Okay, so we'll exit out of this, and then we'll say class map, we'll call it maybe copper, I don't know. And then we'll say match IP DSCP. Well, again, what? Well, this one we set to a value of 1, if I remember right. And so that'll be here. Now remember again that the reason it was 2 is because it grabs that whole octet, or half of the octet, the nibble at layer 2. Now at layer 3, this is going to have a value of 8, but this is the bits that we pay attention to. So we're going to do CS1 here. CS1. All right. Well, let's take a look at what that looks like. Show run. There they are. There's our class maps, but these are just saying this is what we want to match. We're not actually doing anything at all at this point. So now let's do policy map. We'll do this policy map, voice stuff. And then we're going to say what? Well, we're going to say now what we want to do with our class treatment. So we're going to say class, and then we need to say which class. We're going to say the gold class will be first. And what are we going to do with this? Well, we got a couple of options here. And the easiest one that we're going to do is bandwidth. So we'll use, well, it's very straightforward. Now, in this particular case, it's a percentage of bandwidth, right? So we're going to say percent, and we'll keep it low for right now, 25. And then we'll also say class, what did I call it? Copper, bandwidth, what value? Oh, you know what maybe we'll do? We'll set this one. Well, we could go really high. What we're trying to do, depending on timer, maybe we'll create a problem, but we might run out of time here on this video. So we'll just say bandwidth percent 25, same thing. All right. So great. What does that look like? There they are. So we've got our class maps about what we're going to match. And then if we match, what do we do? Great, but these are not applied anywhere. So now what we have to do is go to int. We're going to go to the serial interface, which is this one right here. Okay. And if you're confused about that, you can say, well, show run, and we'll take a look at where I put the IP addresses. And we can see that right here, 00/1/0, that's the interface that I'm working with. But also we can see that based on the module that I put in, the location that I put it in there. You can also do a show int. So we're going to say int s0/1/0. And now we're going to do service policy. Well, what are we going to do? This will be on the output. It's going to be heading in that direction. Or we could do on the input, depending on which direction the traffic is actually flowing. Now our traffic generator is over here. And we're going to make this phone call. So we'll sort of do all the traffic will be moving in this particular direction. So we'll do the input. And then what are we going to call this? Well, what did we use for our service policy name, or our policy map name? Here we use voice. So that's what we're going to call this here. Okay. Oh, bummer. All right. So we'll call the other way, and we'll traffic generate the other way. I forgot about that. Okay. There we go. All right. So we'll just call the other way. And, oh boy, we're getting long here. Well, I'll show you what it looks like when we got it all together. Right, so we have the policies, and then down here we have the service policy applied. So those are our three components. And now what we'll do is we'll make a phone call. And we'll leave this, we'll say 4750001. All right, so we go over here. Okay. So we've got this phone call that's going, and if we were going to run the simulation, we would see a lot of RTP traffic going back and forth. Now let's do a traffic generator. So remember that we are marking the traffic coming into this port eventually with a DSCP value of 1, or a cost value of 1 that gets mapped up to an 8 at layer 3. And I guess we'll go ahead and do that. I guess it doesn't really matter. 11.1, 192.168.44.1. And we'll periodic put 1 here for the sequence number? Oh, we can. All right, great. That's terrific. All right, so what will end up happening here is if I generate a lot of traffic, I don't know, we'll do 0.01. So that we're going to send a lot of these, right? So we can see we got lots and lots of blinking here. Now what we might find out is that if we were doing a mean opinion score on this phone, it would start to bomb out. The call quality would start to decrease because we have a limited amount of capacity here. Now if I go in here to the clock rate and I say, well, config t int s0/1/0, and I say clock rate, right? And I drive this way down. I'm going to drive it down to 64K. Why 64K? Because that's how much you need for a voice call. Okay, fine. Let's go over here. I might not be able to get away with this because of the modules that I chose, but we'll see. I think it's also that's 0/0. It is okay. Oh, you know what? Let's do this. When you have a DTE and DCE interface, only one end controls the clock. Int s0/1/0. Can we do it? Can I get away with it? Clock rate. Okay. What I just did was I slowed down the interface speed. All right. So we're getting long here, and I don't want to just futz around. But here's the point: we have this policy set up. And I'm allocating a certain amount of bandwidth for the voice and a certain amount for our traffic generator. If we are running into a problem of capacity here, what could we do? Well, we would adjust the bandwidth percentages based on the performance that we were seeing on our desired traffic. So in my policy, I might go in here and say, well, listen, I have a problem with my voice, the one that's getting CS7, the DSCP value of 56. And so what I might do here is allocate an increasingly large percentage of the bandwidth as far as my testing goes. And that's how you protect your important applications. All right. Good gracious me. We're well over an hour here. So just to recap really quick, what do we got? We got VLANs and MLS QoS settings here on the switches. We have routing set up here, IPv4 based routing, right? That's important to us. And then we've got the policies set up here. We're also using a serial interface, and the reason that we're using the serial interface is to create bandwidth problems in a small topology. We've got a couple of forms of traffic here, and then we're comparing what happens when we run various flavors of traffic, and we can adjust our policies based on what's happening with our performance or the applications that we want to protect. We also had dial peers that were on here, which is just call routing, which is what we're going to have to do with SIP trunks. Okay. Well, congrats if you got through all of that. If you got questions, fire away, let me know. We had lots and lots of stuff in this build, but the whole point was to get to a couple of different examples where we have a class map, a policy map, and then a service policy that can be adjusted based on our experiences in the real world, right? I can't actually pick up the phone here and see what the quality is. And I can't really see what my throughput is for my traffic generator, but I sure could in a real world scenario where I was transferring voice over IP, or where I was doing FTP or HTTP or even iPerf. So there we have it. Thanks for watching. Thanks for listening. Like and subscribe if I added something to your lives, and may those packets always reach their destinations, no matter what policies you're going through.